things. At the very least, you have to memorize the 7 rules. When to add the exponents, when to subtract the exponents, when to multiply the exponents. You have to memorize that. At the very least. If you memorize those 7 things, you'll probably get a C or a C plus on this section. Okay? If you learn what it is we are doing, which if you go back in your notes, you will see I gave examples of all of these. If you actually learn this and write it out and know what is happening, then you will always do perfectly. Understand? Now, right now, you'll notice all the numbers are little, aren't they? In the real world of math, sometimes those exponents could get big, couldn't they? For example, if we were sending a rocket ship to Mars, we're going to have some big exponents, aren't we? Because it's millions of kilometers away. Everybody understand? So eventually it gets to the point where you're not going to draw it all out. If this was n to the 27th, you wouldn't write out 27 n's. Right? Everybody cool? All right. And 8. Who's doing 8 for me? Who's feeling strong? Elijah, you're on fire, brother. 1. 1 over a to the 4th. Whoo! Look at you. 9. Who doing 9? Zookman. N to the 6th. Absolutely correct. Who's doing 10? Who's feeling strong? Somebody's feeling strong. Who dat? Kevin? What is it? 1 over z to the 6th. Absolutely correct. You's on fire too. Now, N, well, of course you didn't say Z. You said some letter that doesn't exist. I don't know what letter that is. I don't know where that comes in the alphabet because it's not a letter. N to the 12th? Wait a minute. How does this happen? Those are both negative. Which means, shouldn't this go to the denominator? If you have the rule memorized, you're absolutely correct, Ryan. Yes. If you remember that I just multiply, great. What is really happening? N to the negative 4 to the negative 3rd is really 1 over n to the positive 4 to the negative 3, correct? And then that negative would make the base flip again, which makes it n to the 4th over to the 3rd, and then you multiply and you still get a positive. This is what is really happening. This is the very least that you need to memorize. Everybody good? And 12. 12? 12? 12? Max? 12? Give him a shot. I'm feeling strong. 1. Over. C.
4.
Yeah. And I'm even going to choose to believe that you actually wrote that down and it took you that long to read it.
Yeah.
That you didn't just do it in your head. I'm choosing to believe it. Was I right? Good man. That's the right answer. Uh-oh. Number 13. Fractions and exponents. Ooh. What is it? Damn right it's something. It's a little something something. Michael. 3 to the 12th over 5 to the 12th. Now, when it shows up on the screen, which it will in a moment, I'm going to ask, why am I stopping there? Why do I have to stop there? Nope.
Because it says write it as a power. Write all powers.
Okay. So why aren't I subtracting these exponents? It's division.
Because they're not the same value. I'm not base.
Different base. 3 and 5 are different bases. What's 14? Even if you haven't done your homework, you should be able to figure these out as we go along. A squared over B squared. What's 15? 15's a little tricky. N6 over M3. Lovely. Oh, 16. Blech. What is it, Elijah? D. Oh. It is D over C. You had to flip them because of that negative exponent. But what are the exponents? What do you do with exponents over brackets, brother?
That's a 4, not a 1.
Oh, did you read that as a 1? Oh, that's cool. If it's a printing error, yes, it would be D2 over C2 if you read that as a 1. But it is in actuality a 4. So what would it really be? D8 over C8. But if you read that as a 1, you're absolutely right. You'd be fine. Now, why is this one tricky? Because you could have done one of two things. You could have gone over the bracket and had C to the negative 2 over D to the negative 2, or 8, depending on how you read it. And then noticed, oh, negatives can't live there, so it's got to go down there. Negatives can't live down there, so it's got to go up there. The other option is flip it in the first place, D2 over C2, and that changes this exponent to positive 1. Would it change either of the exponents inside the base? No, it doesn't. Now, 17 I am not allowed to ask Elijah about. So who would like to tell me what 17 is?
Elijah.
Well, he messed with me the first time, right, Ryan? Maybe I should ask him.
Do it.
8 saving him. 4b squared over 25c squared. Why? Why is 17 right? Why does the 2 become 4? The brackets make everything a base. All right, it's time to do some moving. Evan, this is your new desk for a while, please. Get your stuff. Please, by all means, take as long as possible. That will make me less angry. Is one person moved enough, or is everybody else going to shut up? Because I have 3 other empty desks to move you to. 4. So everyone else going to shut up? Because I'm more than willing to shut up and say, let's do the first quiz on this, because obviously you all know how to do it, right? Your opinion, when you're getting the grade you're getting in my class, does not apply in this case, Aiden. All right. So the next one, since asking you people is a pain in my ass, I'm just going to start writing the answers, and you can deal with writing them down. Yes, Ryan. Yep. Okay, I will never mind. Okay. This one was really hard to see, but it was 5 and negative 5. This one was really hard to see, but it was that. Any questions? Of course I can explain 21. What do you do with an exponent? First of all, what's the base? X and y, which means this is really x, y to the negative 1, how many times? 3 times. So there would be 3 of them in reality. If you are not bothering to memorize or learn what is happening, you're just following the rules, yes? So if I had for example, number 9, why was it n to the 6? Because you had to multiply over brackets. So if this x wasn't there, what do you do over that bracket? Multiply. What's 3 times negative 1? So you'd have y to the negative 3, correct? Now, if that y wasn't there, what do you do over the bracket? Multiply. So what is it? X to the 3rd. What's not allowed there? Okay, where do negative exponents go? What's the proper word for it? You just said it. To the opposite spot. Okay, yeah, they reciprocate. So right now it's in the numerator, yes? Because we have it written. So it can't stay there. So it goes to the denominator and becomes positive.
Might read it as x times y over y, since it's also a numerator,
Oh, so you did this. X to the 3rd times 1 over y to the 3rd. That's what Aiden just said. So I need to know what you actually wrote, Michael, and then we can talk about it.
I wrote 1 over x, y, and 3rd.
Oh, I see. Okay. I understand. If that were correct, then that x, you can see that it is x cubed, right? The x has no negative.
The reason I put that is because I thought it was just one thing.
Yes, I understand what you're saying. So when you are able to get to here, yeah?
You thought x and y were the same base, not 2 different bases. Yeah.
Oh, I read you. Okay, no. Different letters, different bases.
I just figured because, like, in a longer equation, you can have x and y, they do different things. But if you had x and y separately, then you needed a new one. If you used x and y, that would be a new one.
I understand. But that is not the case. Different letters are totally different bases. So what is happening here really is you have x to the 3rd, and you are multiplying that by y negative 1 to the 3rd. Okay? Cool? All right. Anything else on the first page? I am expecting not a lot of trouble with 81 and 82. Turn the page over. 29 is 1. 30 is a to the 7th. I put the x there because it's just another way of multiplying. Some of you probably thought that it was another variable. If you did think it was another variable, that's a to the 7th with an x afterwards. Because the a's would go together because they're the same base, depending on how you read that. M to the 8th, B to the 12th, which is a very important vitamin that most of us are lacking, B12. Now, 33 is a little bit difficult. Why? The x's are separated. Does order matter in multiplying? Of course not. So those x's have to go together, which would be x to the 8 to the x, idiot. X to the 8th. And what is happening with the y's? So it's y to the 5th. We have to remember there's a 1 there. 34 is 1 over, no, sorry. Yeah, it is. 1 over AB squared. And 35 is A8B12. Is everybody good with the simple stuff? Yeah? Okay. You're going to get lots of practice, so it doesn't matter. Turn the page over, please. I don't want to go over all of these. Oh, yeah, it won't take long. What makes 1a weird looking? I'll give you a hint. I got my big red dot over it. The base is negative. Are negative bases okay? Yes. So this first one is negative a, but I must remember the brackets, to the 9th. And I leave that because the exponent is positive. Is everybody cool? It doesn't matter about bases. So then g is negative g to the negative 6th, because 7 minus 13 is negative 6, yes? Is that allowed? No. Why? Because now there's a negative exponent. So I know it's 1. I know it's going to be over something to the positive 6. Does this guy change? No, because negative bases are allowed. Is everybody cool? Yeah? Now, technically, that negative base with a positive even exponent, what's going to happen to that negative if I actually multiply it all the way out? It would become positive. So you could write this as 1 over g to the 6th. You could. Why do you need to be careful about that? Because if this was a 7, you couldn't do this. Does everybody understand? Is everybody good with that? All right. Number 2 should be okay. It's exactly the same as number 1. I'm not going to worry too much about it. Same with number 3. Actually, number 3 has some of the weirder ones. X to the negative 6. So that is x to the 1 over x to the 6th. E is a little weird. I have y to the 3 over y to the negative 2. What do you do in the exponents? When the bases are the same, you're dividing. What do you do with the exponents? Subtract. So this is 3 minus negative 2. What is that? 3 plus 2, which is what? Positive 5. That's a big problem with most of you guys when you're doing these. You forget your negative rules. Aiden. No. They're all the same thing. 4 is where it starts to get a little bit crazy. Up until 4, you've essentially been doing grade 9 math, yes? In grade 4, we start wading into grade 10. X's go with X's, Y's go with Y's. Why? Why is that the case? They have the same base. So for the X's, I do 3 minus 2. X to the 3 minus 2, and Y to the 5 minus 4. To get me what for an answer? 3 minus 2 is 1, so it's X to the 1. Do I write 1? No. 5 minus 4 is 1, so it's Y. Do I write 1? No. Are you allowed to write that in your own work? Of course. Like if you're going further along and you need to leave a 1 there, that's cool. But in your final answer, you want to avoid them. Cool? I is difficult. Would anybody like to tell me what they got for I? Nobody? What do you have? E squared F 14 and G negative 10. You would leave it like that? Okay, so if it was only E's, is he right? Is negative 4 minus negative 6 positive 2? Is he right? I don't know, Mr. Myers. I'm bad with adding and subtracting. So what should you do? You're going to go out for your calculator. Negative 4 plus negative 4 minus negative 6 is indeed positive 2. So he's okay. What do I do with 5 and 9 for the F's? What math do I do with my exponents when I'm dividing? What? I subtract. What is 5 minus negative 9? That's the same as 5 plus 9, which is positive 14. So he's okay there. Negative 8 minus 2 is negative 10. So this is the right math, but an impossible situation. So where does that guy, where would he end up? On the denominator. So this is correct, except you can't have that. So it's e squared f14 over g to the 10. And then it's done. What changes in number 5? Again, I didn't show you an example of number 5, but you all know how to do it. What would you do if... Oops, that was a bad... What would you do if it was just 36 over 12 and you were in grade 3? You would do that simplification, wouldn't you? You would never leave that for Mrs. Bad Crumble. What would you do? What is 36 divided by 12? What is it? I don't know, Mr. Myers, so where do you go? Calculator. It's 3. Numbers with numbers. They're the same, aren't they? Okay. Now, what would you do if there was no 36 and 12 and no B's? What would you do with A4 and A2? Subtract them. What's 4 minus 2? I like how you asked that questioningly. What's 4 minus 2? 2. It's not 2? You know it's 2, right, Ryan? Don't go to your calculator. It's 4 minus 2, man. A2. Is that a positive exponent? Is that allowed to live there? Excellent. Now, what if there was no 36 and 12 and no A? What would you do with those B's? Swat them because they might sting me. Just kidding. What would you do with those B's? You do the same thing, which is subtraction, right? What is negative 2 minus 3? Negative 5, right? So I would have B to the negative 5. What part of that isn't allowed? The negative 5. So that whole power has to move. Where does it move? To the denominator. 3a squared over b to the 5th. Now, I am imagining that if I actually did a homework check, number 6 wouldn't be done. Number 8 wouldn't be done. Number 9 wouldn't be done. And number 11 and 12 would not be done. Would I be correct?
No.
Okay. So that means we can go on, yes?
No.
Excellent. What do I do with this one? Bases go with bases, yeah? So what do I do with the 3 and the 6? If there was nothing else there, what would the answer be? What math is happening right there? Right there. What math is happening right there? No. It's totally basic math, as a matter of fact. What math is happening right there? Multiply. So what is 3 times 6? 18. Okay? And then all the bases stay together. X's with X's. What math is happening? It's multiply. What do you do with the exponents? Add them to get what? I know I shouldn't wait this long for grade 10s to tell me what 2 plus 3 is. Thank you, Evan. What do I do with the y's? Imagine that. The same thing I did with the x's. 2 plus 4 is 6. Are all those positive? I know, because my computer sucks. Are all those positive? Do any of them move? Nope. Done like dinner. Look at this last one right here. This is the one that gave some of us problems before. What do you do with that 3 out there when there's a base inside? Multiply. What is that? What value is that? He waited patiently for grade 10s to read a number. He still is waiting.
Wait, what is it?
I'm simply asking what value that big red circle is over. Excellent. What do you do with that negative 3? You multiply it in. So, what is negative 3 times positive 3? Negative 9. What is negative 3 times negative 1? I know 3 times 1 is a complicated multiplying question. I feel you might need some more time with it. I'll wait while you discuss with your neighbor what 3 times 1 is. 3. What there isn't allowed? Negative 9, which means it has to move. 7i is exactly the same thing, so I'm not going to go over that one. 8. What do you do with the numbers? 8a. No, there's numbers there with no exponents. What do you do with the numbers? What math is happening right there? Multiply. So what do you do with 7 and 5? Multiply them, which is what? 35. Excellent. What do you do with the a's? You collect them. How do you collect exponents that are being multiplied? Add them. What is 4 plus negative 1? 3. So that is a to the 3. Is that allowed? Yep. And the last one, b and b. What do you do? B to the 5th. Now I check. Is every exponent positive? Does 7 times 5 equal 35? So did I do it right? Excellent. Now let's look at E. What do I do with the numbers? Divide. Does 51 divide by 17? What is it? 3. Abso-smurfly correct. What do I do with C and C? I subtract. What is negative 2 minus 0? Negative 2. Good. I'm glad that question was answered quickly. It's not as complicated as 3 times 1. Negative 2. And what do I do with D and D? 6 minus negative 1. 7. D7. Now, I look at my final answer. Is any of that not allowed? Which one? This. So that has to move. 3 is okay. D to the 7th is okay. But the C's got to move to the denominator. Is everybody good? Okay. Let's have a look at B. Uh-oh, there's 2 operations. What do I do with the numbers first? 4 and 12. Absolutely, you multiply them. What is 4 times 12? 48. Then I've got to divide by 8. What's that? I can't do that in my head, Mr. Myers. That's okay. I give you a calculator. You're allowed to use it. What's 4 times 12 divided by 8? 6. What do I do with the exponents? Because they're all the same. A. What do I do with multiplying first? Add them. What's negative 7 and then negative 5 more? Negative 12. Then I subtract them. What's negative 12 minus negative 4? Negative 8. A to the negative 8. What part of that isn't allowed? Just this. Does the 6 move? The 6 does not move. Why? Because 6 isn't part of the base. It's by itself. So it is 6 over a to the 8th. Now, you cannot get in trouble. How many people have done all 6 of these on the back? So you wouldn't put your hand up right now, right, Avery? 2 of you have done all 6 of these on the back. Everybody else, go. I want you to do all 6 of these. Make sure they are done. If you are having trouble reading them, I will try and tidy it up for you and make them a little bigger. Most of the rest of that should be legible. If you did do all 6 of these, then do that last one that we haven't done yet, which is 11A, just to make sure. Now, you will notice that I use the highlighter, yes, to group things together. Very few of you are carrying highlighters, right? But you will also notice you don't necessarily need a highlighter, right? Do the numbers first, then do the letters that are the same, then do the next letter that's the same, then do the next letter that's the same, okay? Also, you will notice that when did I leave my negative exponents? When did I deal with them? At the very, very end. Because if I try to move stuff around in the middle of the question, I can get a little lost. Especially on these ones in number 12, yeah? I'm going to get my highlighter going. Yo.
If there's an exponent on the outside of the brackets, it affects everything behind it.
Yes. And in grade 9, Evan, what was the acronym we learned for the order we do math in? BEDMAS. So doesn't that mean in this very first one, I need to deal with that 3 out there first? Because it's an exponent that applies to that whole base. Doesn't it? So that's really not 4PQ. It's really what it should be. Do you need a calculator? I have many right now. There's lots that have been left here in the last couple of days. So right now I have a crap ton of calculators. You might want to turn the light on in front of you because you now have a solar-powered calculator. It works? Okay.
Thank you.
No problem. That is part of what I'm here for. With a quick show of hands, how many people have finished 11D? A few? Okay, still some people working on it. So we can't go on too much quicker. Calculator is kind of important for this section, but not super important for this section, because most of the numbers are fairly small. Will one more minute get you through 11D? So, where does that 3 go in 11D? It goes to everything, yes? So I'm going to have negative 4 cubed, p cubed, q cubed, correct? Now, we don't like negative 4 cubed, do we? So what do we do with that? Because we can evaluate that, can't we? We go to our calculator, and what do we find out this equals? What is negative 4 times negative 4 times negative 4? No, that would be 4 times 3. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is? It is negative 64. So there I have negative 64. And that is going to multiply by negative 5p cubed. Numbers with numbers. So what do I do with negative 64 and negative 5? What math is happening right there? Multiply. So what do I do with negative 64 and negative 5? Multiply them. 320. What do I do with P and P? Add them. Why? Because they're the same base and I'm multiplying. What is 3 plus 3? Awesome. We are on fire with the addition now. So it is P to the 6th. What is happening with my friend Q here? There's no others. So it stays the same. Q3. How many people got that right? Good. Now let's look at C. C is weird. According to the rules that Evan reminded us, bed mass. Where do we need to start? Okay, there's no brackets that are part of math, are they? These are grouping brackets, yes? So do I start on the numerator or the denominator when I have something like this? Numerator, because this is saying this is dividing everything up there. So we deal with the numerator first. What is 4 and 6? What is happening to them? Multiply. What is it? 24. What is happening to M and M? Adding. What is 4 plus 8? M12. What is happening to N and N? Adding to get N to the 6th. Is everybody happy with that? Everybody can do that, yeah? Right? Okay. Now, all of that, when that N and 6 show back up like they're supposed to on my thousands of dollars of machine, over negative 3, M6, N6. What do I do with the numbers? What do I do there? Divide, because there's no exponents, are there? What is 24 divided by negative 3? Negative 8! Yes! What do I do with M and M? I go to Detroit and I listen to him rap. But really, what do I do? Which is M to the 6th. And what do I do with N and N? Subtract, which is N to the 0, which is 1, and we never write 1. So I am done. Now, final check. Is anything not allowed? Everything's okay. Why, Evan? Because I see right there's a negative, and I know something is up with negatives. But it's a base. Holy crap, Elijah, using the real word too. Go get a gummy bear. If you want. You're good? Okay. Yeah? No. I know you did. That's just the way it goes, buddy. Sometimes when you're speeding down the highway, you get pulled over and the guy beside you doesn't. Just the way it is. Maybe next time you get the gummy bear and Elijah will have said the right answer, he'll be like, and I'll be like, so it goes. And then Billy Bob's back there going crazy. He's going to start flipping desks if he doesn't get a gummy bear. Right? Yeah, I can tell. You look pretty mean. You never have anything on your face but a smile. You're a good guy. All right. What's happening with F? Barf. What is happening with F? Evan knows what's happening with F because Evan remembers bed mass. What's happening with F?
Brackets exponent.
I see some exponents that need to be dealt with, yes? Where does that 2 have to go? Into the brackets. Does it go to that 5? Yeah. So it's 5 squared. X to the what?
4.
4. And y to the what?
14. No.
Y to the
2.
2. Nice work. What is 5 squared really? It'll catch up. 25. So what do I really have there? 25 x4 y2. What's happening in this side? Does that 3 go everywhere? So I'm going to get 3 to the 3rd, x to the 6, and y to the
7. 8.
We did 3 times 2, so what do we do here? Which is 12. 3 cubed is 27. I checked that on my calculator. X6, Y12. Now what? What do I do with the numbers? Multiply them. What's 25 times 27? What? 675. What do I do with the x's? Which is x to the 10th. What do I do with the y's? Which is y to the 14th. Is any of this difficult? No. Is it complex? Yeah. Right? There's a difference, thank you, between complex and difficult. Yes? The hardest thing we're doing is add, subtract, multiply, or divide. Right? And we can use our calculator to do all of that, can't we? But we got to do that a million times and remember what we've done when we've done it. Therefore, making it complex. Everybody with me? Don't stress about it, just like you wouldn't stress about going for a walk. Walking is very, very difficult. And yet, you can all do it. Some of you are learning to drive. Driving is crazy difficult. Yeah, driving is stupidly difficult. Think about what is going on. You're driving down the highway at 120 kilometers an hour, and there's 100 cars around you all doing the same thing. There's 120 is the speed limit on the Coquihalla. I drive the Coquihalla all the time. Right? You have to trust that all those people know what they're doing. Some of them are texting. Some of them are changing the song. Some of them are beating up their children while they drive, while they put on makeup, while they eat a sub sandwich and drink a coffee. But the cars are not crashing, are they? Because sometimes they do. But for the most it doesn't. Because people learn to do that complicated thing and make it automatic. It's the same thing here. Now, class is about to end. I don't believe that this class is done, except for the 3 people that said they did. 12, A, B, and D. Work on them now.
Are we not going to be looking over our estimates?
Well, we may run out of time for that, Michael, because as was viewed by yourself, it took a great deal of time to find out what 3 times 1 was.
I'm pretty sure it's 18, right?
So, due to that fact, and the fact that all of you had 2 days to do this, and only 2 of you did it, in 48 hours, we don't have time to go over the test right now. Maybe. We'll see.